Okay, hello there. Welcome back to AL Tutoring. Today we'll be walking through Methods Written Exam 1 2006 version. If you guys need any tutoring, you can just email me or I'll leave a Google form down in the description and you can fill it out if you need some tutoring. Okay, let's get started. First question, nice and simple. Let f of x equals x squared plus 1 and g of x equals 2x plus 1. Write down the rule of f of g of x. So what we have here is we're basically just substituting the x in f of x for g of x. So what that will look like is f of g of x is equal to 2x plus 1, this is where we substitute the x, squared plus 1. And remember, when it says to write down the rule of f of g of x, we have to always, like this part, something equals to something. Or else, I don't know, just write it to be safe. Okay, question 2. Find the rule for the inverse function f of inverse of x. Okay. So I'm just going to swap the y and x values around first. Let f of y equals x. X equals 3e. X plus 1 divided by 3 equals to e2y. And we just turn this into a log. X plus 1 over 3. That gives us y equals to log e. X plus 1 on 3. 1 on 2. Remember, we can't leave it as y because it's asking for the rule of the inverse function. That means we have to turn it back into the inverse function, or you lose a mark. X plus 1 on 3. Alright. Let's take a look at the next question. Find the domain of the inverse function. Okay, so we know that the domain of the inverse function is actually equals to the range of the normal function. In this case, we draw it out. The range of the normal function is actually from -1 to infinity. And we said domain is actually equal to -1 to infinity. Just highlight our answer here. Okay, next question, nice and simple. Find the diff of f of x. It's a very simple question. Oops. For this question, a diff of a exponential is just the same as you bring this down here. You diff the top, you bring it down here, and this top stays the same. So diff of cos, that's negative sine x. E, the top stays the same. Okay, let y equals x tan x. Evaluate the derivative of when x equals pi on 6. Okay, derivative of y. You can use the product rule. This is our u, this is our v. No, sorry. Product rule. We know that the product rule is a f of x times g dash x plus f dash x times g of x. In this case, we can let x equal to f of x and tan x equal to g of x. So by substituting it into this rule, we get f of x multiplied by the derivative of tan x, which is secant square x, plus the derivative of f of x, plus the derivative of f of x, which is just 1, multiplied by tan x, equals to, just simplify this, plus tan x. Okay, this is our first mark. second mark comes from substituting x equals pi on 6. Now let's go down here. When x equals pi on 6. Pi on 6 secant square, which is substituting for x equals pi on 6 here. Notice how we have secant squared of pi on 6. How would you solve this? Because we don't exactly know what secant is, right? Well, actually, secant is just 1 over cos squared of x. And 1 over cos squared of x is the same thing as cos x squared. So using that knowledge, we can turn this into pi on 6 multiplied by 1 on cos of pi on 6 squared plus tan pi on 6, that's 1 on root 3. So here, that's pi on 6 multiplied by cos pi on 6 is root 3 on 2. Root 3 on 2 squared plus 1 on root 3 equals to root 3 on 2 squared, that's 3 on 4. 1 divided by 3 on 4 is 1 times 4 on 3. So it's pi on 6 times 4 on 3 plus 1 on root 3. This gets to 2 because it's a common factor. That's a 3. That gives us 2 pi on 9 plus 1 on root 3. Okay. Question 4. For the function, this function right here, write down the amplitude and the period. Amplitude equals to 5, and the period is equal to 2 pi divided by 2, which is equal to pi. Sketch the graphs of the function f on the set below. Label axis-intercepts with coordinates. Label endpoints. Oh, this is a very annoying question, actually. Okay, we can see that this is actually separated into 12 segments. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So we know that each one of these ones is pi on 12. Okay. 5 cos 2x plus. Let's turn this into pi on 12 so we know how far away to translate it. 4 pi on 12 to the left. 1, 2, 3, 4. As it's a cos graph, it should start right here. Pi on 5. Cos graph just starts from the top. Add pi because period. Negative pi on 3 plus pi is 2 pi on 3. 2 pi on 3 is equal to 8 pi on 12. 1, 2, 3, 4, 5, 6, 7, 8. 8 pi on 12 is 2 pi on 3, 5 pi. We sub in f of pi to get 2, 4 pi on 3 cos 8 pi on 3. 3 pi minus pi on 3 causes negative. Negative 5 on 2. Oh, that's way too far down. Negative 5 on 2. Same thing for this side. Should be negative pi, negative 5 on 2. Now we have to find the middle of this point is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6. Actually right here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, because the middle of these points is actually the lowest point as well. 2 pi on 12 is pi on 6. Like so. Okay, we have to find the axes intercepts now. Let's make some space actually. This is a bit of an annoying question where you have to just like brute force your way through it. F of x equals to 0. This is solving for x-intercepts. Cos 2x plus pi on 3 equals to 0. X plus pi on 3 equals to, when is cos equal to 0? We have a unit circle. Cos is equal to 0 when pi on 2 and 3 pi on 2. We can change our domain. No, let's just stick with this. And the midpoint, wait, actually, the midpoint between these 2 points is the, what is this? The midpoint between these 2 points is actually the x-intercept. Judging by that, that looks like it's 1, 2, 1, 2, 1, 2, 1, whoa. 1, 2, 1, 2, 1, 2, 1, 2. Yes, so basically we can just use shortcuts to find. That's 6. Yeah, shortcuts to find the solutions. 2 pi on 6 minus pi is minus 5 pi on 6. That's 10 pi on 12. 10. That's minus 10 pi on 12 minus 5 pi on 6. Negative 5. 1, 2. Oh. Okay. This looks about right. Let's draw it in. I like to label my graph, just in case your school wants it. Negative 5.2. So we've labeled the, oh, we have not labeled the axes intercepts yet. 1, 2, 3, 4, 5 pi on 12. 11 pi on 12. What is this? Negative pi on 12. 2, 3, 4, 5, 6, 7. 7 pi on 12. Yes. Question 5. Let x be a normally distributed random variable with a mean of 72 and a standard deviation of 8. Let z be a standard normal random variable. Standard normal means that the mean is equal to 0 and the standard deviation is equal to 1. This is mean, and this is standard deviation. Use the result that the probability that the standard normal variable is less than 1 is equal to 0.84. What does this mean exactly? So if we were to draw out our standard normal curve, this looks a little scuffed, but that's fine. Let's say this is 0, right? Like the center. That means that 50% is here on the left and 50% is on the right. Now, by this logic, 0.8, when it's less than 1, the area is 0.84. If we know that this entire area is equal to 1, and that this doesn't actually touch the line, but this is 1, and then it's saying that this is equal to 0.84, that's basically saying the area under here is equal to 0.84, which means over here is 1 minus 0.84, which equals to 0.16. as the area of this entire curve has to add up to 1, as it's the standard normal random variable. The probability that x is... Okay, we can use this for this question. The probability that x is greater than 80. First of all, we don't exactly know where to go from here, right? Probability that x is greater than 80. We're not exactly given a... I mean, we're given a mean and a standard deviation. Typically, for these questions, when you're given a mean and a standard deviation, what you want to do is apply the transformation to it, which is x minus the mean divided by the standard deviation. So in this case, x is greater than 80. It's the same thing as saying by transferring to the standard normal random variable, it's the same thing as z is greater than applying this transformation. So x is 80 minus by the mean that which they give, 72, divided by the standard deviation of 8. That gives us probability that z is greater than 8 divided by 8 is 1. Okay, now we have this. We can go back to this graph here. Look, we've already worked out that when it's greater than 1, when probability of z is greater than 1, it's equal to 0.16. That means that we can just write it right here. We've already solved it when I was explaining. Equals to 0.16. Okay. Next question. Find the probability that x is between 64 and 72. Okay, so same thing. We have to convert it into standard normal random variable form first by applying this transformation. So probability 64 minus the mean, 72, divided by the standard deviation in between z, because we're turning x into z, as z has a mean of 0 and a standard deviation of 1. This is 72 minus 72 on 8, which gives us probability of -1, z, and 0. Okay, we don't exactly have to work. Okay, -1 to 0. What's that saying? It's basically from here. 1 second. You just redraw this right here. -1 to 0. It's just this part right here. And we know that this is 50%. We also know that from above 1 is 0.16. Notice how this is actually symmetrical, right? That means this part right here is actually the same, it's also 0.16 because, you know, it's symmetrical, although this graph isn't a really good depiction of it because I'm not that good at drawing. And by that, we can use the rule that probability of z is greater than 1 is also the same as the probability that z is less than -1. So by using that logic, we can say that the area from -1 to 0 is the same as 0.5, which is this entire thing, minus 0.16, which gives us 0.34. It's a nice question. Okay. Find the probability that x is less than 64 given that x is less than 72. Okay, what is this even talking about? First of all, let's break it down by writing it out, okay? Let's see what it's asking for. The probability that x is less than 64 given that x is less than 72. Okay, so we can actually use the formula, that one formula in the formula sheet, which is this rule right here. Probability A given B, so it's A intersect B over the probability of B. In this case, this would be our A, and this would be our B. So probability of A intersect B, what is this? X is less than 64 intersect X is less than 72. If you're not sure, you can always draw out a number line. Let's say this is 64, as 72 is greater than 64. Oh, that's a really scuffed line. 1 second. 72. When they intersect is at this point right here, when X is less than 64. Intersection just basically means when they meet up. Yeah. So X less than 64 intersect X is less than 72 is the same thing as X is less than 64 divided by probability of B, which in this case is X is less than 72. Just get rid of all this. What we have here now is this right here. Probability X is less than 64 and X over X is less than 72. And look at these numbers. 64, notice how it's 64 here, 72, 72. Well, typically VCAL wouldn't make you do extra work by just doing everything out. So we can actually take a shortcut and look back at our question. You can see that 64 actually turns into a Z value of -1. Probability is Z is less than -1 over, you can see that 72 actually turns into a Z value of 0. Less than 0. And we looked here, a Z value of less than -1 is equal to 0.16. And a Z value of less than 0, right here, right here, where this is 0, it's actually 0.5. So that leaves us with 16 on 50, as we're just moving these 2 decimal places to the right. Simplify that further by doing 8 on 25. That's our answer. Next question. The probability density function of a continuous random variable x is given by this. Find the probability that x is less than 3. Okay, so typically for any continuous random variable question, you would have to integrate. Typically, one rule you have to remember is that the integral from 1 to 5 of the given function is actually equal to 1. Actually, in this case, it's 1 to 5. The area from 1 to 5 is equal to 1. Let's see what this graph would actually look like. If we do a rough sketch, that's 5, 5 on 12, 1, 1 on 12, and then we have these 2 lines. So what it's saying is just this area underneath from 1 to 5 is actually just 1. So it's basically find the probability that x is less than 3. What this is basically asking for is the area of the graph from 1 to 3. So let's find that. 1 to 3, x on 12 dx. Can add 1 to the power and divide by the new power. x1 squared, and then divided by 2. So that's over 24. 21. Then we get 3 squared on 24 minus 1 on 24. 9 minus 1 is equals 8 on 24, which equals 1 on 3. If the probability x is greater than a equals 5 on 8, find the value of a. How would you approach this question? So we know, we can go back to this graph right here. You know that this, let's just say this is A. Right here. When it's greater than A, so this entire area right here, it's basically saying that this area is equal to 5 on 8. Now, you could do it this way, where you would find an integral from A to 5 of x on 12 dx. But I feel like you end up with really large numbers. Let me just show you. Equals to x squared on 24, 5a. You end up with 25 on 24 minus a squared on 24 equals to 5 on 8. Now, this doesn't... Actually, no, this could work. I'll show you two different ways to do it. This is the first way. First way to do it. Okay. So we got 25 on 24. Let's rearrange that. 25 on 24 minus 5 on 8 equals a squared on 24. You can multiply that by 3, so that becomes 15 on 24. So that becomes negative, oh, my bad. That becomes 10 on 24 equals to a squared on 24. A squared minus 10, 24 equals 0. A squared equals 10. A equals plus minus root 10. Are we done yet? No. We have to remember that A is actually greater than 1 in this case. Because look, A can't be at any point before 1, as this is our domain right here. A can't be any point before 1 or after 1. After 5. So that means that A is equals to root 10. This is our first way of doing it. Our second way of doing the question is actually to flip this around. So probability that x is less than or equal to a is equal to 3 on 8. How does this make sense, you might ask? You can go back here. Look, if this area right here is 5 on 8, that means this area on the left is actually equal to 1 minus 5 on 8, as this entire area has to add up to 1. If this is 3 on 8, we can basically just say that the probability that x is less than a is equals to 3 on 8. Yeah, and that's just from 1 to a, just do the same thing again. I'm just integrating. But basically, you get the point. You'll end up with the same answer if you do it this way. Okay, a very nice question indeed. Okay. This isn't in the study design anymore. You don't need to worry about that. Okay, a normal to the graph of y equals root x has the equation y equals negative 4x, where a is a real constant. Find the value of a. So right off the bat, I'm seeing that this is worth 4 marks. It's actually a lot. Okay. How I would personally approach this question is, I would first find the derivative in terms of y, because I'm trying to get to the normal first, right? So in order, we have to find the tangent of y first, which is just x to the power of minus 1 from the power, multiply the original power to the front, which is equals to 1 on 2 root x. That gives us our tangent, not our normal. Notice how, very important, notice how it's actually bolded right here. You have to pay attention to that. That means VCOM wants you to notice it's a normal, or you'll lose a lot of marks. By using the formula m1 times m2 equals negative 1, we can substitute this. This is to find the normal of a graph. And 1 times 1 on 2 root x equals negative 1. That means our normal, this is our normal, is actually equals to negative 2 root x. This is our normal gradient. And now we have an x value which we want to solve, and we're also given a normal gradient here, negative 4. So what we can do is actually equate these two gradients together. So we're trying to solve for x. Negative 2 root x is equals to negative 4. Notice how we don't actually include this x value right here. It's because this x value belongs to the y equals mx plus c formula. It belongs, we're just trying to use this gradient value so we can find the x value here. So that gives us root x equals 2, negative cancels out, 2, x equals to 4. We have an x value now. In order to find the y value, we simply just sub it back into y. Y of 4 equals root of 4, which equals to 2. We end up with a coordinate point of 4 and 2. Now, since we have a coordinate point, we can come back to this equation right here, where we find the value of a. Look, we actually have our y value and our x value now. So 2, we just substitute back in, 4 plus a, 2 equals negative 16 plus a. That means that a equals 18. Nice. Equals 18. Next question. A rectangle XYZW has two vertices, x and w, that's these 2 points, and on the other vertices, y and z, on the graph of y equals 9 minus 3x squared. So this is now quadratic. As shown in the diagram below, the coordinates of z are a and b, where a and b are positive real numbers. Find the area A of the rectangle XYZW, so this entire rectangle, in terms of A. Okay, what I'm noticing here straight away is that we actually have a B value we want to get rid of. Because it's saying in terms of A, right? We can't have a B value and say that it's in terms of A. So how do we find a way to link B to A first? Look, we're actually given the formula of this quadratic. And what a coordinate point. We're given the x value of this coordinate point, which is just a. So we just have to sub it into the quadratic to get our y value. 9 minus 3a squared. That means that our b value, which is just the y value, is equals to 9 minus 3a squared. So another way of writing this coordinate will be not a 9 minus 3a squared. And now we can come back to this question and find the area of the rectangle. So we know this length is 9 minus 3a squared. We know this part is equal to a, as you can't have a negative length. This is just on the graph. And this part is also the a. So that combined is equal to a plus a, which is 2a. So area of a rectangle, length times width, that's the width times the length, which is 9 minus 3a squared. Keep in mind, find the area A of rectangle in terms of A. Just remember to write equals. I don't want any of you guys to be losing marks on that, just in case you get a strict examiner. Alright, find the maximum value of A and the value of A for which this occurs. Okay. Find the max value of A. Does that sound familiar to what we have to do? So we're given a function here. We're given a quadratic function of our area graph. Let's just plot it in terms of A, where we have 0, 9 minus 3a. That is 9 3 squared. Basically what I'm doing is I'm just trying to find the points. Something like this. Our graph would look something like that. Our area graph at least. But look, our value of A is actually a positive real number. So that means that this entire part actually doesn't exist. So what it's telling you is to find the maximum value of A and the value of A which occurs. So at this point right here, we have to find the value of A. And in order to find the maximum value, we actually have to find the derivative. So A dash of A is equals to, hold on, let me just expand the top function first. It'll make it a lot easier for us to read. 18A minus 6A cubed. It means that the derivative of A is equals to be 18 minus 18A squared. Okay, now we have our derivative. We can let it equal to 0 because we're trying to find the maximum point where the gradient is 0. 0. That means that 18 minus 18A squared is equal to 0. 18 equals 18A squared. A squared equals 1. A equals plus minus 1. Remember, always circle this, where A and B are positive real numbers. Whenever they give you a domain, remember to circle it. Okay, so we know if it's a positive real number, it has to be greater than 0. Therefore, A is equal to 1. So are we done yet? No. We have found a value of A, but not the maximum value of the function. So what we have to do, sub it back in. That gives us equals 18 minus 6, which is 13. Oh wait, well, I can't do math. 12. Yes, 12, right there. This will be 1 mark. This will be the second mark. The third mark will be to find the diff. Yep. Okay. See. Okay, question 10. Jo has either tea or coffee at morning break. If she has tea one morning, the probability that she has tea the next morning is 0.4. Okay, what does that mean? If she has tea one morning, the probability she has tea the next morning is 0.4. If she has coffee one morning, the probability that she has coffee the next morning is 0.3. Interesting. 0.3. And we know that these probabilities have to add up to 1. So we can just do 1 minus 0.3 here, 0.7. Suppose she has coffee on a Monday morning. Let's just say this is Monday, Tuesday, and Wednesday. What is the probability that she has tea on the following Wednesday morning? I want to circle that. That she has tea. So we're looking, okay, coffee on Monday morning. The probability she has coffee the next morning is 0.3, 0.7. Okay. So we're actually looking for when in Wednesday, when she has tea on Wednesday morning. So that's this path right here, because of this tea, and this path right here. You can actually just write a tree diagram as you're working out, but I prefer, after doing this, I would also do probability of CTT, which is just coffee TT, plus the probability of coffee T, which is equal to 0.7 multiplied by 0.4 plus 0.3 times 0.7. 7 times 4 is 21, 0.21 plus 3 times 7 is, this is 28, plus 0.21, which gives us 0.49. That is our answer. Okay, the last question, I'm pretty sure, yes. 5 marker. Oh no, this is a fat one. Okay, part of the graphs of the function f of domain of real values is shown below. If the shaded area is 45, you need to find the values of a, which is here, a, m and n, where m and n are the x-axis intercepts. Okay, we're given an area, so that certainly means that we have to integrate something. Okay, look, we're given this right here. If we were to integrate from 0 to 3 of our given function, x squared plus ax plus 12 dx, and we know that this area is actually equal to 45. This allows us to set up our equation to solve for a. So we just have to integrate this, minus x3 to the power 3 plus ax squared on 2 plus 12x. We equals 45, sub in x equals negative 3 plus 9a 2 plus 12, 24, 36 minus by sub in x, that's 0, 0, 0 minus 0 equals 45. 3 to the power of 3 is 27 divided by 3, that's 9. And notice how the negative is on the outside. It's not, the power of 3 doesn't apply to it. So that means it's negative 9. 3 to the power of 3, 27 divided by 3, negative 9, plus 9a on 2, plus 36, minus 45. I just want to move everything to the right to make it nice and easy to read. 36 minus 45, that's equals to negative 9. Negative 9 minus 9 plus 9a on 2 equals 0. You get negative 18 is equal to negative 9a on 2. 36, we get rid of the negatives, move the 2 over. 36 equals to 9a. That means that a has to equal to 4, 9, 18, 27, 36. Now that we have our value of a, this would be... We can go back to this question and solve for m and n, which are the x-axis intercepts. So we let f of x equals 0. We know that f of x is equals to negative x squared plus ax plus 12 equals negative x squared plus, we know that a is 4 now, 4x plus 12. We let this equal to 0. Negative x squared plus 4x plus 12 equals 0. Take out the factor of negatives, so we flip everything. Factorize this. Factors on negative 12 that add to negative 4. That's negative 6 and 2. So x minus 6, x plus 2 equals 0. It gives us x equals negative 2 and 6. We're not done yet though. It's saying for values of m and n, but we have an x value right here. Let's go back to the graph. Notice how n right here, n is actually less than 0 and n is greater than 0. This means that n has to equals to negative 2 because it's less than 0, and negative 2 is less than 0 of course, and m has to equals to 6. So that gives us our answer. That should be the end of the paper. Alright, thank you guys for watching. If you have any questions, just comment down below. I'll try to reply to you as fast as possible. I'll also just let me know if I've made any mistakes and any tips on how I can improve my teaching. If you're interested in tutoring, just shoot me an email or comment down below. Alright, I'll see you guys next time. Bye bye.